My name is Yiyi, and yes, as Akawa-sensei has introduced, my background is energy economics, and my main research work here in WIAS is to investigate the role of industries in the energy transition towards specific climate goals. If it is in Japan, it is achieving carbon neutrality by 2050. And the approach I use for this investigation is integrated assessment models, and some details would be introduced. The details about what specific modules in these IAMs are improved. This will be introduced probably later in this presentation. And first, let's take a look at why we investigate the industry sectors. And of course, from the perspective of greenhouse gas reduction, they are the large emitters. They are the large emitters of greenhouse gas, and it is extremely difficult to decarbonize them in the short run, especially for those energy-intensive industries. For example, iron and steel making, cement. And this is because the demand for those industrial products, the bulk materials, the demand would not decrease easily. And also for national strategies, some of them receive subsidies. And also it takes time to upgrade the infrastructures. For example, in a steel making factory, a blast furnace may be operating over 40 years or even longer. And these difficulties can easily be observed in developing countries, but this is actually particularly true for Japan. And compared to other developed countries, Japan actually has a higher share of industrial final energy consumption. It is definitely higher than the G7 average and actually closer to the G20. And especially given the current national climate goal, achieving GHG neutrality by 2050, it is particularly important for Japan to address the industrial decarbonization. And yes, we understand the difficulties of decarbonizing industries by its nature, and also we understand the ambitious national climate goal of Japan, and we start to wonder, is this feasible? Is the transition towards carbon neutrality by 2050 in Japan, is this feasible? And we can hear those invisible voices. This is a survey conducted by Taeguk Data Bank in 2021. They asked more than 20,000 companies, and among all these industrial stakeholder respondents from various subsectors of industries, there are 17.9% of them said that it is impossible to achieve this national climate goal, and also there are over 40% saying it is very difficult to achieve that. But it is difficult to ask all industry stakeholders, each of them, and even we asked each of them, it is difficult for an individual or one entity to understand the holistic view of what is going on in Japan. So we need some tool that can draw a conclusion whether such system transition are feasible or not. And these what tools are actually used to draw such conclusion in a probably more scientific way? IAMs, integrated assessment models. IPCC has relied on them, on those process-based integrated assessment models, to quantify the mitigation scenarios and also the different pathways for staying within the specific climate policy targets. If globally we have the 2 degree or 1.5 degree target, and for Japan it is 2050, the net zero goal by 2050. And IAMs are very powerful tools. They are technology rich. They can cover the dynamics of mitigation options. They can cover the dynamics of techno-economic systems. They can cover the dynamics of decision making, and they give back the least cost technology combination with multiple constraints to achieve the climate goals. But there are also a lot of dimensions that IAMs cannot cover. For example, the dimensions of for example, the social acceptability and the political, especially those social cultural constraints, and also institutional and political constraints. And also, as we mentioned earlier in the survey, the behaviors of all actors, IAMs are not very good at covering that. And also, given a global-based model, it is when we're scaling down it to national level or to even higher resolution, a lot of details, technological and economical details we may lose these details. So in one word, to draw a better conclusion of whether such system transition, whether this is feasible or not, to draw a better conclusion, and also to show a better to describe the pathway towards it in a better more closer to the reality. The modeling of industrial decarbonization, this should be improved. And this is the objective of my project here in WIAS. By improving the energy and use technology parameters of industries in those IAMs, the feasible long-term transition pathways towards carbon neutrality can show to what extent and how should the industries contribute to the role of industries. But actually, at the second year of the project, as I mentioned, a lot of social cultural dimensions, a lot of institutional and also political constraints. Those soft constraints, it is very difficult for IAMs to cover them. It is not enough just improving the current technological parameters of them just by mapping them in a more detailed way. This is far not enough. So what I actually should do is to investigate it by better modeling the industry sector in IAMs. So the better in the sense of considering the interdependencies between energy service demand and supply. And I will give an illustration of why this what this interdependency part is and why it is important. And in most energy system models, the optimization logic is to find the least cost energy system, the technology combination that meets the projected energy demand. And this is the demand side, which is exogenous, and this is the supply side. But however, there are something in the middle. For example, there can be some changes in the demand side that lead to an increase in the energy supply. For example, the integration of demand side energy resources. This will definitely increase the energy supply, the supply of electricity specifically, and this can be some spillovers. And also in the reverse, in the opposite way, some changes at the energy supply side, for example, with a higher penetration of renewables, the increase in, there can be increase in the energy and material demand to produce those PV panels, those wind turbines and EV charging stations. So these interdependencies should be better modeled. So this is my point at what is I mean by a better modeling of industry sectors in IAMs. And that's why I extended the original system boundary. When we only focus what happened within the energy system, and this is the position of industries and those with plus. So these modules would need to be improved so that when we talk about the decarbonization of industries, we are not only focus on the industries because it is an intermediate sector. The demand of the final energy consumption of industry is actually determined by a lot of other modules. So let me use the same overview map. These are I put some dots of the research output. What I have done for the improvement of each module in those integrated assessment models, and the shape refers to the types of the research output, and the color is just the topic or what module it is. I listed the main research outputs, and these are the two core papers that can basically summarize what I meant to do in this project, and I will skip them. And I have used 11 minutes to introduce my motivation, why I wanted to do this, and what and why improving the modeling is important. And in the rest 8 minutes, I will introduce two main works. I think they are ongoing works under review, one under the second round of review and one under the first round. And I think they can be interesting because only talking about the technical details of modeling is quite boring. The first one is the perceived feasibility and barriers to Japan's net zero transition. We interviewed 109 experts, and the response rate is actually quite good. We have over 60% of experts accept the interview. And the original list of experts, this is how we screening them. We screen them from the list of IPCC authors, and also from the Web of Science, and also from the Kakenhi data. It is a funding database. And we ask them their desirability. What is the most desirable level of emission reduction goal in Japan? Although the government, the Japanese government, has announced their goal, achieving GHG neutrality, achieve net zero by 2050. But is it for the expert as a person? Is this desirable? As same desirable as you think? And do you think this is feasible? And we also asked them to assess multiple barrier factors. We have 23 in all. We asked them to assess each of the barriers and their likelihood and their impact. And we also collect their some basic information such as affiliation, discipline, and their working years. And we found that actually this is the table of the result of desirability, and this is the result of feasibility. And we actually found that, yeah, it is quite desirable. The experts, based on the experts' perspective, more than half of the respondents, they mentioned that this 100% emission reduction, this is quite desirable. And also when we asked the feasibility along with the stringency of the climate goal, 80% reduction, 90% reduction, over 100% reduction. Of course, the share of lower possibility of feasibility, of course, more red here. But we found something interesting, and the second row, this is the modelers or the experts who have some knowledge about IPCC reports and who have some knowledge about IAMs. Those modelers believe that there is a statistically significant difference between what they assess feasibility of the previous climate goal, which is 80% of emission reduction. There is a quite significant difference here. And also, if we map the desirability and the feasibility, we map it in desirability in this way and feasibility in this way, there is a weak but positive correlation. And among the 22 barriers, 23 is the other. It is an open-end suggestion question. Among the 22 barriers, the concern of nuclear power generation, the lack of national strategies, and the lack of capacities of local actors, they come as the top of the barriers. And actually, they are indeed the barriers, the factors that are harder to compare to the economical or technological barriers. They are very difficult to be involved in IAMs. And to wrap up what we have done for this interview, the desirability and the feasibility, and the most important barriers given the context of Japan. And we also found that there are no simple answer to answer why experts perceive some barriers as high risk. And also there are no silver bullet solutions. For example, just by removing one barrier, then all of a sudden the question is solved. No, it is not the case. It is just the complexity of those issues that calls for the further researches and explanations of system transitions. And the second part is how the interdependencies between energy service demand and energy service supply is modeled. We do this by to capture this part. We mapped the life cycle material inputs with a national input-output framework with extended electricity supply sectors. This table compiled by the team of Professor Washizu, and then linked it to integrated assessment model GCAM. The illustration, the overview of the model is here. And why model linking? I do not have time to introduce model linking, but model linking is actually I have emphasized a lot of times to improve the modeling, The model linking is the approach we finally end up with. It has some advantages, and it also has different types. We summarized the different types of linking, and they definitely serve different purposes. And okay, I don't have time to introduce those. Probably this our results by investigating, by including those interdependency parts, shows that the current projection of energy and material demand is actually quite underestimated, and the amount is not small. It's 0.2 to 0.7, etc. And this is actually not very small. And I do have 3 points. I hope I can use 1 more minute. the last 3 points I want to summarize for my work in WIAS. So first, decarbonization transition. This needs multi-dimensional understanding, and the current approaches, the one I have been working so far, the current approaches are dominated by the techno-economic traditions, and this is definitely not enough. We should be more opening to talk and to discuss, to involve different research communities and talk with researchers from different disciplines. The second one is when we talk about industrial decarbonization, it is not solely about industry sector itself, and also considering the national of context, we have another paper talking about the possible changes at the labor supply part, the context of each country. It is also very important. And also the final one is the message to modelers. And model linking can be a choice, but it should serve a specific purpose, and those specific purpose would determine the technical features of model linking. Yes, this is what I would like to share today.